Okay, so here we find another typical example of a problem you will find in probably most of the exams. First of all, whenever we find this kind of problems, the best thing to do is to just make a big graph so we can understand clearly the problem. Okay, so here are gonna be my axis. I'm gonna trace in another color how this is gonna work. So I'm just another green and here. Okay, so this thing is gonna be of a magnitude 300 and an angle of 45 degrees. Okay, so pretty much we can solve it in an infinite number of ways. Well, not infinite, but like 3 or 4 different ways. I'm gonna use the one that I'm most comfortable with, but if you just think that some other way is better, it works for me. Okay, so for part A, I need to find the highest point. For that, I'm gonna use this formula, the one that has nothing to do with time. Why is that? Because I don't like to do like a lot of calculations, and the way if it can work in a most directly way, it's better for me. Okay, so the initial velocity squared minus 2 times the gravity y minus initial y. Okay, so from here we know that at the highest point, velocity is going to be 0. Okay, initial velocity we can compute it easily. It's just the magnitude times the sine of the angle. In this case, it is 45. All this stuff squared minus 2 times the gravity, that's 9.81, and we want to know the y. Okay, so if we solve for y, we're gonna get just that y is equal to 300 sine of 45. All this stuff is gonna be squared. Everything all over 2 times 9.81, and this number is gonna be really big, and I've already done it for you, but use your calculator and get it done. It's 2,293.57 meters. Okay, so that's the first answer. For the second one, let me change color for a nice red, I think. For the second one, I think I'm gonna use a typical one that is like how long is it in the air. So I just get like the typical formula, that's y equals y0 plus the initial velocity in y times time minus a half of the gravity times t squared. Remember, this part is negative because gravity goes down. Okay, so the final position is going to be 0 in y is going to be 0 because after it's thrown and it does this part, it's going to return to 0. So the final part is going to be 0. The initial point, it was 0. The initial velocity, it's 300 sine of 45 times the time, we don't know, minus a half of 9.81 times t squared. Now, here we can use the general formula, or we can use let's do some basic algebra. I think I'll go with the algebra right now, but you're more comfortable with the uh, general formula, aka chicharronera. Just do it. So let me just solve. If I just like separate this part, I just get sine of 45 t is going to be equal to a half of 9.81 of these parentheses times t squared. This squared can go away with this t. So if I solve for t, I'm just going to be left with this t. Oh, I hate this part. T is going to be equal to, well, what happened here? Oh, there. No, let me erase it. I hate this part. I don't know why that happens. I'll just write t is going to be equal to, what? Yeah, 300 sine of 45 over a half of 9.81. And that's gonna be, if you do it in your calculators, 43.24. Okay, so that's the total time that the ball is in the air. And finally, I need to know which is the horizontal reach of the cannon. There you can use like that for the formula that we used in the last slide, or we can use a typical one. That is the one that I'm gonna use right now because it's part of the recipe I've been talking to you about. So for here we got C. Okay, what is the horizontal reach of the cannon? For here we have like, I don't know, the typical formula that is x equals to x0 plus initial velocity in x times t. That's going to be equal to initial position is going to be 0. Initial velocity in x is 300. We're in x-axis, so that's cosine of the angle that's 45 times the time. That's the one we just computed. That's going to be 43.24. Okay, so after doing some numbers, that is going to be 9,172.58 meters. Okay, I insist that there are like several ways of solving it. This is the one I feel more comfortable with, but you can choose the one you want the most. Okay.